Okay, so let us start with the session. I hope the screen is visible to all of you. Okay, fine. So in previous lecture session, in the yesterday's session, we had started off with, my laptop isn't working. Just a minute, huh? It's not working, not responding. Okay, yeah, we had started off with microprogrammed control, right? And I had explained you the control organization. As we discussed previously, that it is divided into two parts. There are two ways in which we can design the control organization: hardwired control and microprogram control. Right? Hardwired control we had seen in the previous chapter. That was basically designing using hardware components, using flip-flops, registers and all. Whereas microprogram control includes a control memory which consists of microprograms. Right? You need to write microprograms in it. And generally these programs are written in assembly language. Right? Now, when we started off this, we saw that the computers which follow microprogrammed control organization has two types of memory in it: main memory and control memory. We had seen the difference between the main memory and control memory, where their main memory is available to all the users, right, to store their programs. It is alterable. We make changes to our programs. They get changed into the main memory. It consists of machine instructions and the data. Whereas in control memory, we saw that they hold fixed programs, fixed microprograms. They are designed, it's a type of ROM only, control memory. So by programmers, the microprograms are written and they cannot be altered by normal users. Okay, so we can only read those programs. We cannot write into it. We cannot make any changes. So this was what we studied, that microprogram consists of micro instructions. Each micro instruction generates micro operation for doing the following task. These are the tasks which now we have an idea. Whenever an instruction occurs, whenever we want to carry out some instruction, what are the steps to be executed? So first of all, these micro operations would be a sequence of these steps only. Right? What we do in this, we fetch instructions from main memory, we evaluate the effective address. After that, the micro operation which is specified by the instruction gets executed, and then the control is again returned to the fetch the next instruction. Okay. After that, we had studied this block diagram, which was very important to understand how does this organization work. We had seen that there is a control memory, right? ROM. It contains of all your microprograms, right? It receives address from the control address register. We'll be calling this register as CAR. Okay, अब आप बुक में कहीं पे भी देखोगे तो आपको it is designated by the acronym CAR. So this control memory receives address from CAR. And when it receives address, what happens is from that particular address, the instruction is fetched and it is stored in the control data register. Okay. Control data register would, this instruction would be converted to a control word, would generate a control word, right? And the instruction would get executed, and side by side, whatever from the instruction itself, some bits are used for generating the next address, right? So this for next address also, data is passed from the control data register to the next address generator. It is also known as microprogram sequencer. Okay, so the task of the next address generator is to generate the next address to identify which instruction is to be executed next. And once that instruction is identified, again, that instruction's address is stored in the control address register, and then the cycle would keep repeating. Okay, so this is what we studied in yesterday's session. Now, let us see exclusively the task of the address sequence register. Okay, so the next topic which we'll be starting on today is address sequencing. Okay, first of all, so this control memory has different microprograms. Microprogram consists of micro instructions. Micro instruction has micro operations, right? So now we will need to learn that how to generate the next micro instruction address. How is that next micro instruction address generated? So there are four different approaches, four different possibilities for the next address generation. First possibility is incrementing. We'll see it through the diagram itself. Incrementing our control address register by 1. So whenever see, what does the control address register contain? The control address register would contain the address of the micro instruction, right? To be stored in control memory. इसके अंदर क्या होगा? You will be having the address of micro instruction to be stored in control memory. आपको कौन सी इंस्ट्रक्शन मेमोरी में लेनी है? Find that address is specified in this control address register. So now one approach is, after execution of this particular instruction, immediately increment the value of CAR by 1, so that in sequence, if my current instruction, suppose this is my instruction, if this is stored at address 100, my CAR would be incremented by 1, and whatever is written, whichever instruction is mentioned over here at the next address would be then loaded to the control memory. Why? Because CAR is incremented by 1. So this is the first approach. Let us see it through this diagram. Here, first of all, what to draw? Control memory. Okay, this is a selection of address. How are the addresses selected? So first of all, this is my control memory. In this control memory, the addresses come from CAR, control address register. Now, where does the addresses come into the control address register? We have seen this diagram. In our diagram, control address register में address कहाँ से आते हैं? Through the next address generator. Now, as we said that for next address, there are four different approaches. For the next address generation, there are four different approaches. So look at this multiplexer. This is a 4x1 multiplexer. Okay, ये चार possibilities में से एक address would be transferred to the control address register. इतना पता चला सबको? The middle three blocks. Are you all with me understanding these concepts? Okay. So we have taken a 4x1 multiplexer which would transfer the address to the control address register. Out of this, the first approach we saw was, in my normal instructions, what would happen? My control address register would just need to be incremented by 1. So what is done over here? This part, the control address register is incremented by 1, and that incremented address is provided as the first input to my multiplexer. Clear? Itna clear? Okay. Now let us see the next approach. So this is for my normal instructions. Okay. Now second input to the multiplexer, that is second approach of my address to be generated, is subroutine. So where does the second address into the multiplexer go from? It would go from the subroutine register. Now, what is the subroutine? It is nothing but our function call. Whenever a program is being executed, these are the sequence of instructions being executed. वो एक एक increment करते जाओ, and the sequence of micro instructions would get incremented, right? Now at this particular time, if there is a function call, what would happen? I need to store this particular return address. Function call यहाँ पे jump करेगा, यहाँ पे मेरा function है. This function would get executed, right? This function would get executed, and this address, the next address, return address, should be stored somewhere, right? So this would be stored, this address would be stored in the subroutine register. After this particular subroutine gets executed, you are going to come back to this particular location, right? So in this subroutine register, what would we be storing? So here, this would store, SBR would store the next address for returning. Okay, तो यहाँ पे देखो क्या किया है, ये incremented value. Obviously, we will have to increment because it is the next address. यहाँ पे if the function call is at 2000 location, next address to be executed is 2001. ये पूरा execute हो गया, function call पे उस जगह पे गया, आपका पूरा address execute हो गया, ठीक है? Through my in my control word, these things are mentioned, and that data, that function got executed. After that, again my program counter अपना जो value होगा, it would be incremented by 1, and this incremented by 1 value has to be stored in subroutine register. Okay, so look over here, incrementer में तो गया ही है. After incrementer, this particular value, the same incremented value is stored in the subroutine register. Okay, and that incremented value is provided as a second input to my multiplexer. The second approach क्या हुआ? Whenever function call arises, okay, at that time what we need to store, तो वो लिखा है. Now let us move on to the third possibility. First, let us see unconditional branch. Third approach is unconditional or conditional jumping. We will first discuss unconditional one. Okay, unconditional branching or jumping. You are moving from one location to another, right? You want to jump from one location to another, like jump instructions. In that case, whatever is specified, whatever branch address is specified, I have written something like jump to particular location. So whatever is mentioned over here would become your branch address. Okay, this is the branch address where I need to go. So what is provided? This is the branch address. This is for this arrow out of control memory. आपकी जो instruction होगी, control memory के अंदर control word होगा. Instruction के अंदर ही लिखा है कि इस location पे jump करो, right? So that particular branch address is provided as a third input to my multiplexer. Clear? Okay, so this is for, this wala arrow is for what? It is for unconditional jumping. Next is conditional branching. ये दोनों एक ही है, ठीक है? In approach 3, conditional or unconditional. Conditional branching. Now see, conditional branching depends upon some condition. Whenever some condition holds true, right? When some condition holds true, we need to jump to a particular location. Now, what kind of condition can it be? You have number of flags available, like you have jump if 0, like sign bit flag, right? Depending upon the sign, you need to carry out some instruction. So you have sign bit flag, you have overflow flag, then carry out of adder. Okay, depending upon these specific, like you have input output status conditions. These are the different conditions which can be checked. ये हम आगे पढ़ेंगे, ये mode bits क्या है, ठीक है? Mode bits of instruction. So these are the different conditions which can be checked for changing the control of execution, that is providing a specific address and moving to that, storing that address to your CAR. Okay, so this how does this checking takes place? That is checked by the branch logic. Okay, it would decide whether to go to this particular location depending upon the condition. Only if the status condition is satisfied. These are our status conditions. Okay, you have status bits. we'll be seeing each every bit in detail, right? So depending upon these status bits, if these status bits hold true, if they satisfy the condition, then that particular address is transferred to my multiplexer. So look over here. Here you have status bits, okay? From the control memory in the instruction it would be mentioned कि आपके instruction, I'll be teaching you, the next topic is instruction format only, right? So in that we'll be seeing there are in the format itself, for branching and condition checking, there are bits allocated, right? In my entire instruction format, you have specific bits allocated for checking the condition for branching, for the branch field, address field and the micro operation field. ठीक है, तो आपने जैसे instruction format उसमें पढ़ा था हमने in hardwired logic, we had seen the basic computer instruction format which had opcode and address and the I bit for addressing mode. Similarly, here we will be having micro operation fields, will be having branching fields, will be having condition checking fields, right? So what is this? It would be helping you out here. This branch logic would, depending upon the status bit, this is my selection line, okay? Here the inputs are given. Depending upon that, address is provided to the multiplexer, okay? Only if this condition holds true, then the address would be transferred to the CAR. So these are the three approaches. Moving ahead to the last approach, ये वाला arrow बाकी है अभी, mapping logic. The last approach which we'll be talking about is mapping logic. Some mapping algorithm is followed on the opcode. See, suppose this is my IR, instruction register, okay? It has like, suppose this is my opcode, okay, and here is my address. Now, some kind of logic mapping algorithm is applied over here to convert this particular opcode to a particular address which can be stored in our CAR. Now, the size of CAR is 7 bits. We'll see, मैं अभी next topic वही ले रही हूँ. This control memory, we'll see the diagram, but this control address register is of 7 bits, right? So now some kind of mapping logic is applied over here, okay? Like 0 is added to the most significant bit और यहाँ पे 2 और zeros append किए. ये mapping logic है, okay? So now what happened is my opcode got converted to 7 bits like this, okay? And this address is stored in our CAR. We'll see this, ये mapping कैसे करेंगे, but this is how some kind of mapping algorithm is applied, some kind of mapping logic is applied on our opcode to convert it to 7 bits so that it can be stored in the control address register. Okay, so these are the 4 ways. So यहाँ पे देखो instruction code में से opcode fetch करेंगे, उसके ऊपर कुछ mapping provide करेंगे, and that mapping would convert it to a particular address, and that would be transferred through multiplexer to our CAR. So now is this figure clear to all of you? All the 4 approaches. Now if I ask you to draw it on your own, would you be able to do it? What was the first one? Normal incrementer. Normal instruction. Second one, the incremented value is stored in subroutine and then transferred to multiplexer to indicate that this is a subroutine call. Okay. Third point we saw was a normal unconditional jump where no conditions are checked. Whatever address is mentioned in the instruction address in the instruction register in my instruction, whichever address is mentioned, directly jump to that particular location. Okay, so that is the branch address is provided in my instruction itself, and that address we pass over here. Okay, next one was conditional jump where we need to check status bits. Okay, we had seen different possibilities of, we have different flags which are needed to be checked as a part of condition, and only if the condition is true, these were the flags which we discussed. Okay, so looking to these flags, these are some of the examples of status bits. right? So looking to these status bits only, if the condition is met, then branching takes place. Okay, and that address is provided over here. And the last one was mapping logic. Mapping logic means you from the instruction code itself, you provide some, you carry out some kind of mappings in such a way that your opcode gets converted to a particular address, and that is stored in the CAR. Okay, so this was all about address sequencing. Okay, so this entire flow chart, this entire figure for see, I'll quickly show you this. ये चार हमने अभी पढ़ा: incrementing, conditional branch, mapping process, and subrouting. Okay, so this is the how the selection of address for control memory takes place. हमने जो address sequencer पढ़ा, ठीक है? So this mapping is explained over here. Is it visible? Yeah, so this mapping is explained over here. So 1011 directly transferred and पीछे 0 or 0, and this becomes a micro instruction address. Okay, it is of 7 bits. आगे हम देखते हैं. I'll show you why 7 bits. Okay, so this is explained over here. Now let us move ahead to see the, is this clear? Addressing part clear? ये 7 bits वाला I'm explaining you now, okay? Why is it of 7 bits? And we'll see the microprogram example. First of all, let us see the computer hardware organization of a computer having microprogrammed organization. Sure. Now, let us see this. On selecting highlighter, my screen got hung. Okay, chalo. Now let us see this computer hardware configuration. Right, for understanding first microprogram control, an example of microprogram, we'll first see the hardware architecture, computer hardware configuration, right, for a computer that follows microprogram organization. As discussed earlier, a computer that follows microprogram organization has two types of memories. One is the main memory and the other is control memory, right? So here, your main memory, we know that main memory would be storing all the programs and all, right? So this main memory is associated with 4 registers. So 4 different registers are associated with main memory. Which are those registers? Now we all know the purpose of registers. Okay, what is address register for? What is program counter? What is data register? What is accumulator? Okay, so here we are discussing about 4 main registers which are associated with our memory, main memory. Now, look at the size of the memory over here. What is the size of the memory? 2048 cross 16. We are taking the size of main memory over here as 2048 cross 16. Earlier in the previous chapter, what was the size of the memory that we had taken? It was 4096 cross 16. Cross 16 था कि 12 था, क्या था? This was the memory we had taken, right? Now here, the example shows that we are taking 2048 cross 16 size of main memory. This is the size of my main memory. Okay, now if this is the size of my main memory, how many bits would be required to specify the address? What is 2048? Yes, correct. 2 raised to 11 cross 16. Okay, so my memory would require 11 bits to specify the address. Okay, it has 2048 words of 16 bits each. तो यहाँ पे ये जो size होगी वो मेरी कितनी होगी? 16 bits की. And here I have 2 raised to 11 addresses, and hence I will need 11 bits to specify the address. Okay, so now when I say that I have 11 bits required for address, What would be the size of this program counter address register? We know that program counter and address register would be storing addresses, right? So here the size of these two would be 11 bits. And hence in the figure, if you see that here it is mentioned like this, 0 to 10 means 11 bits. Itna clear? Now, what does your DR and AC store? Data, right? Operands, data. What was the size of the memory again? 2048 cross 16. So what did I tell you? Each word is of how many bits? 16 bits. And hence the size of DR and AC would be 16 bits. Look at the figure over here. 0 to 15. Hence DR is of 16 bits. AC is of 16 bits. ठीक है, तो पहले मैं अभी साइज आपको दिखा रही हूँ, देन विल सी द फ्लो कि हाउ इज कहाँ से डेटा कौन से रजिस्टर को मिलता है. इतना क्लियर? नाउ लेट अस टॉक अबाउट कंट्रोल मेमोरी. कंट्रोल मेमोरी, द साइज ऑफ कंट्रोल मेमोरी इज 128 क्रॉस 20. Now, when we talk about the control memory, which were the registers associated with control memory for storing addresses? हमने वो फिगर देखा था, तो एड्रेस स्टोर कहाँ कहाँ पे होता है? It's stored in CAR, control address register. Then it's also stored in SBR, subroutine register, right? So now, what would be the size of these two registers? What is 128? It's 2 raised to 7. And hence, the size of the registers that store address in my control memory is 7 bits. ठीक है? Cross 20. What would be the instruction format size over here? Instruction अपनी अपना माइक्रो इंस्ट्रक्शन जो भी होगी, वॉट एवर इज माई माइक्रो इंस्ट्रक्शन, it would be of how many bits? It would be of 20 bits, because this is my control memory, right? It has 128 words, which is 2 raised to 7, right? So 128 words, each of 20 bits. So एक इंस्ट्रक्शन, एक माइक्रो इंस्ट्रक्शन की साइज क्या होगी? It would be 20 bits. Understood? After this figure, we'll be seeing the instruction format. Okay, so that is 20 bits. Now look over here. This is my control memory. You have SBR and CAR associated with it. तो ये पूरा जो block है, this entire block is your control unit. This is your main memory. Okay. Now here, see, like we saw that data between registers can be exchange of data between registers can be carried out through bus. Similarly, here we are using a multiplexer which helps us. ये मैं पूरा remove कैसे करूं? Yes, so similarly here we have a multiplexer which helps in transferring data to different registers. Okay, now let us see. ये हमने पूरी size देख ली, and we have seen the different components which are included over here, right? We saw that we have a main memory, we have a control, we have a main memory block, we have a control memory block, which are the different registers associated with main memory, right? And which are the different registers associated with control unit, control memory. Accordingly, the size of the registers are mentioned. Okay, now let us see where does the data come from to each of these registers. First of all, when we talk about data register, where does the data register receive data from? So the data register would receive the data from memory. Okay, it would receive the data from memory. This is the first arrow. It may receive the data from accumulator. ठीक है, हमने कोई ऑपरेशन किया, this plus this is this, and then we need to transfer the data for carrying out some calculations. So again, where can it come from? It can come from accumulator, and it also comes from address register. Okay, एड्रेस रजिस्टर का जो एड्रेस रजिस्टर के अंदर एड्रेस रजिस्टर की प्रोग्राम काउंटर right? From in my program counter, data comes from address register. So these are the three arrows in through which my data register would receive its data from accumulator, from memory, and from, I am getting confused, मैंने कहीं ऐसा पढ़ा था, from address register. Okay, but it's the same arrow. Address data is transferred from address register to program counter, and that data gets transferred to your DR. Okay, then comes address register. Address register again has data coming from two different sources. One is from program counter, ये वाला जो arrow है वो यहाँ पे आ रहा है, ठीक है? And again the second arrow here comes from data register, ये वाला. Okay, in my address register the data comes from data register and program counter. We'll see how it gets transferred, which are the different instructions. ये सब हम connect कैसे करते हैं? Last time also in the previous example of our common bus, हमने designing जब पढ़ा, in that case we saw that which are the different instructions, and on the basis of those instructions we provide the control signals to different registers. Like if my content of accumulator gets changes for a particular set of instructions, we are loading that particular register. Okay, so मुझे कौन से register से कौन से register में data की जरूरत पड़ेगी, depending upon that this type of connection is being made. And in PC the data directly comes from AR. Okay, in from AR we get data to in memory also. Address register मुझे memory में से कुछ fetch करना है, तो I need to have data from address register. Now ALU, this block will have data from accumulator. Okay, आपने कोई calculation किया, उसको वापस accumulator के साथ आप like AC के अंदर, like you are fetching data from DR, you are fetching when you are carrying out add operation, what you do, अगर एक ही operand दिया है तो one operand the data would be coming from data register and the other would be coming from accumulator. Okay, so this is how your adder and logic unit would receive inputs from DR as well as accumulator. Okay, then finally this कंट्रोल एड्रेस रजिस्टर में डेटा कहाँ से आएगा? अपने ये AR में से ही आएगा, ठीक है? और ये हमने आगे देखा कि we have seen the entire block diagram for it, address sequencing. Okay, so here also the data would be coming, these two blocks are also connected. So this is how the entire computer hardware organization is, computer hardwares are organized in a microprogrammed environment. Clear? Now see, what we will be doing is in the next class, when I told you that the size of instruction register and all is kahan gaya? Here it is 20 bits, right? So now we are going to understand this in detail in the next class. We don't have time now, so I'll not be able to continue with it, but just have a look at this diagram. Like we studied the common bus system, we had placed different registers involved in designing a basic computer, and we had provided it different signals and connected it to a 16-bit common bus and multiplexers. Similarly here also, this is our diagram, this is our hardware diagram, which consists of two types of memory and the different registers involved in it. Clear? All of you? So today we we have completed 7.2 in detail, which was addressing, right? And we started off with microprogram example. ये 7.2 addressing हमने पूरा detail में देख लिया, address sequencing, right? And now we have started off with microprogram example. The computer configuration is covered. Now next we'll be seeing micro instruction format. Chalo. So now if you have any doubts, you can ask.